Math, this is a new unit on functions, and we're going to start off with operations on functions. So we've already done a little bit of that without calling it this by this name. It really has to do with when we multiply two binomials, we FOIL them out to get a expanded polynomial. That's putting two functions together. It's multiplying two functions. So you're going to see the different operations that we can do with functions here. Basically add, subtract, multiply, and divide. So the first thing you need to understand is just some notation. So if you have function f plus function g, and again, those are just names. You could call them the red function and the blue function, or you could call them the John function and the Mary function. I mean, they're just names for functions, but it's saying that they're two different functions. You don't call everything f of x. It could be something else. So if you have f plus g and then an x, that's the same as saying function f of x plus function g of x. Now that's something we haven't done in this class. You did that in Integrated Math 2, but we'll do it here. We'll practice a little bit of that, how to add functions. Same thing for subtraction, f minus g times x is f of x minus g of x. Multiplication, now that is what we've done. F times g, x, is f of x times g of x. That would be FOILing two binomials, for example, to expand them. And division of functions, f of g x equals f of x divided by g of x. Okay? So first thing I want to do is practice some addition, subtraction, because we haven't done that in IM3, but you should have done that at some point in IM2. Okay, so what we're going to do here is we're going to add these two polynomials, 3x to the fourth plus 6x squared minus x plus 7, and you're going to add that to 2x to the third minus 2x squared minus 5x. So the way to do that is set up a table, and up here is just headings. You're not adding these numbers in. This is simply a column, the x to the fourth column. This is the x to the third, x to the second, x to the first, and x to the 0. That just means a constant number. Okay? So for example, 2x to the 0 power, x to the 0, anything to the 0 is 1. So it's 2 times 1 is simply 2. So that represents the constant, in other words. Okay? So what you do is you place this polynomial up here in the appropriate column. So x to the fourth is 3x to the fourth. You don't have an x to the third term here, you see, so that's going to be, you can either just leave it blank or put 0. Then 6x squared goes in the x to the squared, x to the second column. This is x to the first, so that's minus x. Don't forget the minus sign, any signs that go with it. And then 7 goes in the constant column, okay, the x to the 0, we call that. Now we take this one, same thing. There is no x to the fourth term. There is an x to the third term. There's an x squared term, minus 2x squared goes in the x squared column. There is an x term, 5x, negative 5x rather, and there's no constant term, no x to the 0 term, so that's 0. And now you simply add. 3x to the fourth plus 0 is 3x to the fourth. 0 plus 2x to the third is 2x to the third. 6x squared plus negative, remember you're adding these. You're adding a negative, so 6x squared plus negative 2x squared is 4x squared. Negative x plus negative 5x is negative 6x. And 7 plus 0 is 0. So that's how you add two polynomials. So don't try to do it in your head. Make the column, make the table like this. Make the different columns, even if you don't have a particular term, list it up here. And then just go ahead and add your two polynomials here. So I'm going to leave this one for you to do. Okay, now subtraction is done the same way, except the way I recommend you do it, this is my way of doing it, is rather than have a subtraction, turn that into a plus sign. And so turn it into an addition problem. And the way you do that is by changing that to a plus and then distributing this minus sign all the way through. So that becomes minus 2x to the third, that becomes positive 2x squared, and this becomes positive 5x. Okay, so again, I set up the columns exactly the same, put a plus sign there. This first polynomial remains the same. That doesn't change, okay? Again, you can put a 0 there if you want. Now the second one, we don't have an x to the fourth term. Now there's the negative 2x to the third. You distributed that negative sign there. There's the positive 2x squared from there. And there's the positive 5x's right there. Now you have an addition problem again. So it's 3x to the fourth. 0 minus 2x to the third is negative 2x to the third. 6x squared plus 2x squared is 8x squared. Negative x plus 5x is positive 4x. And since this is a polynomial, it should have plus signs in between like that. And there's the negative sign there. And then 7 plus 0 is 7, so there's a plus sign there. And so that's how you do a subtraction. So I'll leave this one for you to do on this over here. All right? Okay, now let's get down into some of these. So this one is saying you're going to multiply g times h, these two functions of x, okay? In other words, you're just going to leave the variable x. You're not going to plug in a number here. So that's just simply a FOIL, okay? Although you'll notice we don't have just an x there, we have an x squared. So you just do it the way you would do a FOIL. 4x times x squared is 4x to the third. And what I advise you to do is stop the video, try to do it on your own, and then watch and see if you did it right, okay? All right, now 4x times 5x is 20. 4 times 5 is 20, and x times x is x squared. Now 5 times x squared is 5x squared. And 5 times 5x is 25x. So these two terms combine. So it's going to be 25x. So it's going to be 4x to the third plus 25, I said 25x squared, 25x squared plus the 25x here. Okay, so this entire sheet is in AB format, so you go ahead and do the B problem. It's done exactly the same way. All right, now let's do a division problem. So function g divided by function f. Now this is something different. We haven't seen this before. Okay, so we're going to go ahead and write function g over function f just like this asks us to do. So it looks like this. Okay, so now we have that. Now the trick to these is this is a polynomial, a quadratic that you can factor. And so if I go off to the side, it's got to multiply to negative 15, and it's got to add to negative 2. Oops, add to negative 2. And when I do the two numbers, I'll find that the two numbers that we need are 3 and negative 5. Okay? And those two numbers will do it. So that means this is going to become, I'll come down here and write this. Up on the top, we still have x minus 5. And down here, we have x plus 3 times x minus 5. Okay, that's this factored. Okay, so now you see x minus 5 on the top and bottom. You can cancel those. And so your final answer is simply 1 over, whenever you cancel something, there's nothing left. It's not a 0, it's a 1. There's a 1 there on top. And you still have the x plus 3 on the bottom. And that's your final answer right there. Okay, so you go ahead and you do this one over here on your own. Okay. Now down here, you're given three functions, f of x, g of x, h of x. Again, f, g, and h are just names. Okay, so it could have been called, it could have been called red, blue, and green function. Okay, it's just names. It's saying that if you put a variable and input x in, you'll come up with some output that we call f of x. It's basically, remember what that means? It means y. Those are all y, but they're different y's because they're different functions. So we could call it y1, y2, y3. Okay, they're just the output. Okay, so all you're doing here is plugging a number in. So f of x equals x minus 12. So for 4a, it's f of 10, because that's what they're telling us to plug in, equals 10 minus 12. So f of 10 equals negative 2. Over here you're using g, this one right here. Usually I'm just going to do the A problems, but I'll do the B problem this time. There's a couple of more on the next page. So g of 2, so it's going to be g of negative 2 rather, equals, it's 5x, so it's 5 times negative 2. That's what you put in for the x, minus 12. 5 times negative 2 is negative 10, minus 12, equals negative 22. So that's what g of negative 2 equals. Put in negative 2 into here, you come out with negative 22. Okay, we'll go to the next page. And there you have h, two of them that involve h. So you go back to the previous page, I would copy that function up here, and then plug in a 10, plug in a negative 2. Okay, so I'm going to go ahead, I think, and write those functions up at the top. So we'll do that. Okay, and there you see the three functions from the previous page. So for this one, let's do the a problem together, h of 10. And this is the h function. Okay, so 10 squared is 100, plus 4 times 10, minus 7. So 140 minus 7 is 133. Okay, so that's how you would do that. So you do the b problem. Okay, now we're going to come down here and we're going to add two functions together, and then you put the 9 in. Remember, this is g of x plus f of x, so you add them together first, and then you put the 9 in. So here's g and here's f. Okay, so I'm going to go ahead. We see that the highest order of either of these is first power. So we don't need any x squareds. I'm just going to draw a table with an x 1 and x 0. If you want to write c for constant, meaning that there's no x, you can do that instead of x 0 if you'd rather. We do this, make our table. Okay, and it doesn't matter which one goes on top. We'll go ahead and put the f on top, so it's x minus 12. And remember, we're adding these two, the plus sign right there, and 5x minus 12. When you add those together, you get 6x minus 24. Okay, so now that we have that, we come over here and we say g plus f time to the, and your input value is 9, so this is g plus f right here. I should have put g right there, f plus g, that's it. So we're going to say this, it's 6 times 9, that's the x value, minus 24. Okay, and 6 times 9 is 54, minus 24, that's going to equal 30. Okay, so that's your answer for that. Okay, and you go ahead and do this one, same two functions. Okay, I'd still like you to write this out, because the idea is to practice this, not just to copy it. So write this out, be sure you know how to add those two functions, and then plug 4 in instead of 9. All right, next one is a subtraction. Okay. So we're going to do that. We're going to do this. And this one is h. So h has got an x squared term. So we're going to need an extra column here. And again, these are just headings. You have the x squared column, the x to the first column, the x to the 0 column, which is the constant. Okay, so it's g minus h. You got to be careful you get it's a subtraction in the right order. 5x minus 12 is going to go on the top. So there's no x squared term for 5x for g. We're going to put g up here, and we're going to put h down here. Okay, so it's 5x, x goes in the x to the first column, and negative 12. Okay, now we're going to use the rule that I said. It's minus h, it's minus this. So I'm going to say up here, I'm going to say minus x squared plus 4x minus 7. And then I'm going to distribute this negative sign to make this negative x squared. It just changes all the signs. That's all you have to remember. Minus 4x plus 7. So that makes this down here an addition problem, now that I've changed all those signs. So it's negative x squared minus 4x plus 7. Okay, so now you're adding. Okay, now that you changed the signs, you're not subtracting anymore, you're adding. So it's 0 minus x squared is minus x squared, and then it's 5 minus 4 is plus x, and negative 12 plus 7 is plus 5. Okay, now here's a tricky little point. You're going to square the x first, and then you're going to put the negative sign on. Because if you look up here, if you had gone ahead and done this, the original function, you would have taken x squared, whatever that is. Let's say it's 3. 3 squared gives you 9, and then you would have multiplied it through by minus sign, make it minus 9. So here you square the x first, and then you put the negative sign. Okay? So the x in this case is 2. So it's going to be 2 squared. I'm going to put that in parentheses because we do that first, and then you put the minus sign on after. Plus, x is 2, plus 5. I'm going to come over here, and I get 2 squared is 4 with the negative sign, negative 4, plus 2, plus 5. Negative 4 plus 2 is negative 2, plus 5 more is 3. And that's your final answer. So watch out. Negative signs can be tricky on these problems, okay? All right, you're going to go ahead and do the exact same problem with a 3. Again, though, I want you to write this out and be sure you know how to do it. You should cover this up ideally and go ahead and do this. You got a lot of space over here to work with, okay? All right, let's keep going. So now it's g times f. So that's these two. So that's like foiling, right? So g times, it doesn't matter when you multiply which one goes in front. So it says g, so we'll put g first. That's 5x minus 12 times, and f is x minus 12. And now you FOIL it. 5x times x is 5x squared. 5x times negative 12 is negative 60x. You don't have to do this in your head. Get a calculator. Negative 12 times x is negative 12x. And negative 12 times negative 12, that gives you positive 144. And then the two middle terms combine. So negative 60 minus 12 is negative 72. Okay, and now you're ready to plug in the value that here, which is a negative 2. So again, be careful. You do the negative 2 squared, and then you multiply by 5. So it's going to be 5 times. Okay, and there's a lot of big numbers here, and I gave you almost enough space. So that's negative 2 squared is positive 4. Positive 4 times 5 is 20. Negative 72 times negative 2 is positive 144. So you got positive 144 plus 144 is 288. That's positive. And then you have a positive 20 here. So it's 288, 298, 308. Again, do this on a calculator. You don't have to do it in your head. Okay, 308. Okay, and check me if you think I get a wrong answer sometimes. It'll happen. Okay? That's it. That's all you have to do for that. All right? Okay. This one down here looks tricky. It's not. Instead of giving you a number, they give you a variable t. In other words, it's saying it could be any number that you do the same thing with. So what are you doing? It's g times f. It's the same thing we just did up here. I'm going to do it again. And we're going to FOIL it out. 5x times x is 5x squared. 5x times negative 12 is negative 60x. Negative 12 times x is negative 12x. Negative 12 times negative 12 is plus 144. And now, okay, so the next step is to combine these two central terms here. So it's 5x squared minus 72x, same thing we got above, plus 144. And now all they're saying is plug t, and it could be any number in for x. So it's 5t squared minus 72t plus 144. And that's it. That's all you have to do. No number to deal with the crunch. You just put the t in for the x. Okay, and that's that. All right, you do 9. All right, G plus F. Okay, so let's look at G and F. I think we've added those before. It's this and this. So again, you only have an x to the first as your highest. So I'm just going to make a 2-column table. Okay, so up top it's just your headings, x to the first and x to the 0. Again, you can call that C for constant if you want. Okay, and I just need 2 levels there. So it's G plus F, G plus F. So G is 5x minus 12. And F, we come back here, is x minus 12. Okay, and I'm going to add those. So 5x plus x is 6x. Negative 12. Okay. So 5x plus x is 6x. Negative 12 plus negative 12 is negative 24. Okay, and now we're simply going to come over here and plug in the negative 2 there. So 6 times negative 2 minus 24. So that's negative 12 minus 24 is negative 36. Okay. All right, you do that one. You get a positive number. Makes it easier, I think. Okay, G minus F. Okay, so G is 5x. Let's draw our table again. It's going to look just like the last one. Put your headings on. Okay, so it's going to be 5x. The top stays the same. The first polynomial stays the same. But the subtraction one, which is x minus 12, we're going to come over here and change it. So it's minus x minus 12. And that's going to be minus x plus 12. Okay, so I'm going to put a plus sign here, minus x here, plus 12. You may say that doesn't really make the problem easier, but sometimes it really does. I think adding is better. Adding negative is better than subtracting. Okay, so here we go. So it's 5x minus x is 4x. And negative 12 plus 12 is 0, so you just simply have 4x. I'll put the 0, but you don't have to. And so you got negative 2 here. So it's going to be 4 times negative 2. That's all you have there. Equals negative 8. And that's your final answer. Okay? All right, you do this one over here. Okay, now we're doing some divisions here. And the key to these is to remember to factor them. These are all factorable, okay? And I hope I left you enough space to do that. So I'm going to do my factoring. I'm going to kind of try to do my factoring over here and do the other problem over here. I'm not going to do this one for you, so I'm going to have a little extra space than you might. But let's come over here. So let's factor this. So we got to find 2 numbers that multiply to negative 3 and add to 2. Okay? Multiply to negative 3 and add to 2. So the 2 numbers are going to be negative 1 and 3. All right, you'll eventually come with that. So that's going to add to 2. So, and then we have, notice we have a coefficient that's not a 1. So we're going to write 3x over negative 1 and 3x over 3. All right, this one doesn't reduce, so it's simply going to be 3x minus 1. This one reduces, cancel, cancel. Remember, it cancels, doesn't go away, it doesn't disappear, it becomes a 1. So that's 1x, and that's a 1 on the bottom. Okay, so this one becomes x plus 1. All right, so on the top, so let's go ahead and do, we did that one. Let's do this one over here. This one's a little easier. It has a coefficient of 1. So they have to multiply to 1 and add to 2. Okay, so that's going to be 1, right? 1 and 1. 1 times 1 multiplies to 1, and 1 plus 1 adds to 2. So that's simply going to be, down here I'll write it, x plus 1, x plus 1. So now I got to stack them on top of each other. Okay, it's f over g, this one over this one. So I'm going to come over here and write that, but I'm going to write it in factored form. 3x plus 1 times x plus 1. That was 3x minus 1. Over x plus 1 times x plus 1. That's this one factored like that. And what you see is that this cancels with this. And so this is your final answer. However, there is one final condition you have to state. X cannot equal -1, because if x equals -1, -1 plus 1 is 0, and remember, you can never have 0 in the denominator of a fraction. So you have to state that condition that x does not equal, cannot equal, that's an equal sign with a line through it, -1. So this, the whole thing including that, is your final answer. Okay? All right, you go ahead and do this one over here. I'm going to come down here, do one more. And actually, it's the same one. The only thing we did in this case is we put a 2 in. So I'm going to just go to this answer right here. I would like you to redo the problem, okay? I'm going to look for that. Okay, now we're not using -1, so we're okay. So there you just plug the 2 in. So it's 3 times 2 minus 1 over 2 plus 1. So that is going to be 6 minus 1 is 5 over 2 plus 1 is 3. And that gives you 5/3. That's an improper fraction. That's fine. You can leave it as an improper fraction. Okay, so over here it's the same thing. This problem is the same as this problem. You're just going to plug in the number. I do want you to do this. I want you to do it a second time. I want you to practice it, okay? The repetition is going to help you learn. Okay, so that takes care of the answers for this particular lesson.